Earth, this is Mars. We are ready for the event. This is MDRS Crew 132 here at the Mars Society's habitat on the surface of the Red Planet, transmitting back to Earth our weekly report. This is day 8 as a crew together, and we've been a tight crew, not knowing each other coming into this. We are now one big family, happy to be here working together, and would love to share something about ourselves and our life on Mars with all of the folks back on Earth. So I am Commander Nick Orenstein, and I am originally from Dallas, Texas, in the United States. And before I came here, back on Earth, I was a PhD student at the University of Southern California studying astronautical engineering. And my research there has applications here on Earth for harvesting water on the surface of Mars from the rocks so that we don't have to rely on supply depots to bring us our water, but can get it using in situ resource utilization, or ISRU. So now my wonderful crew is going to go around the table and describe themselves and share with you.
I'm Usha Langappa. I'm XO for this mission.
And I'm Danny Young-Smith. I'm the crew biologist.
And back on Earth, we create
our own astrobiology majors.
And I'm originally from San Francisco, California.
And I'm originally from Denver, Colorado.
And before coming to Mars, I was doing research in biotech and at NASA Ames Research Center.
And I also worked at NASA Ames Research Center with the same mentor that Usha was working with oxidative stress responses in algae.
My name is Charles Parrish. I'm the Green Hab officer here at MDRS, and I'm from Raleigh, North Carolina, back on Earth. And I've been working and studying at North Carolina State University. I study bioengineering, biological sciences, and permaculture design there. And I was interning down at NASA's Kennedy Space Center this summer in the Advanced Life Support Labs, working on the new veggie system that's going up to the space station to grow food for the astronauts.
My name is Michael Bouchard. Back on Earth, I'm from St. Louis, Missouri, United States. I'm the crew geologist for Mission 132. And back on Earth, I was studying geology and geophysics at Missouri University of Science and Technology, where I did research using satellite imagery and remote sensing to study fault systems in the Egyptian desert, as well as working on developing rover technologies with a group of engineers and scientists. And I also worked at Johnson Space Center over this summer.
I'm Hiroyuki Miyajima, crew engineer here. I'm from Yokohama, Japan. I'm a professor at the university in Tokyo, and I'm doing research space habitat design for Mars.
My name is Ian Etter. I am the crew journalist. I'm not really from anywhere in particular. I've been a lot of places, lived a lot of places. And back on Earth, I am an artist. I am an adjunct faculty at the University of Iowa and a fishmonger.
So we're a wide-ranging crew of scientists and artists, and it's been a wonderful experience to have such diversity of knowledge and skills and character here in the Mars Desert Research Station, the close quarters of one happy family. Right, do a little dancing stuff or something.
Oh, wait! Okay, good. Oh. Didn't see you there.
So we're working with bacillus that we're trying to isolate from the soil here. And we took the other day out on an UVA, we took soil samples at 3 different depths in the soil. And we tried to maintain aseptic technique in the field while in the EVA here, which was an interesting challenge in and of itself. But then we brought the samples back in here and plated them on a general growth medium. And we've got, you can see a little bit of growth on the plates. And we are attempting to isolate the organisms. We also brought with us back from Earth a couple of bacillus strains that we've isolated from the Mojave Desert as an analog environment to Martian soil. And what we're going to try to do is compare how these organisms do by themselves versus in mixed communities when we put them in the soil.
And we also brought back from Earth with us some algae, just from any kind of lake or small pond that you would find freshwater. And we're also going to mix them with the soil here at MDRS to see how they react to the other organisms in the soil, which Usha said we had growing today on our plates. And we hope that they'll be able to grow better, hopefully, with these soils, just to see what kind of growth pattern it has and what kind of effect it has on our algae.
We're mostly interested in the response to oxidative stress. Our work back on Earth is largely about reactive oxygen species within the cells, and so we're looking at how organisms here tolerate the environmental stresses of the harsh Martian environment,
Such as temperature, UV radiation, and desiccation.
Working in the lab here in the Hab has been an interesting challenge because it's a very minimal lab setting. So we've had to get pretty creative and do things like use a blowtorch in the place of a Bunsen burner to try and keep our work sterile.
And we are also sharing the lab with Michael over here on his geological methods.
Hey! I'm working on 3 different projects for my time here at the Mars Desert Research Station. As crew geologists, they all have a geology load to them. So the first project I'm working on is geologic field mapping. So I've done geologic field mapping on Earth, terrestrial geology. And I'm going out into the field and collecting data and building a stratigraphic column of this region where we've landed, and seeing how what I usually do in the field is changed or more difficult because of being in the EVA suits and in the Martian environment. My second project is an equipment study and logistical study, seeing how the 18 to 19 different tools you take out into the field when you're mapping, your radios, walkie-talkies, GPSs, rock hammers, hand lenses, how those are affected by the suits. The third project I'm working on is sample collection and analysis. So we've collected these samples from different locations out in the field. We're looking for some subsurface cyanobacteria that may be able to live in this area. We're pretty excited because our mapping has shown that this area has had many different generations of water resources flow through the area, from sedimentary deposits, fluvial deposits, to even marine deep sea deposits as well. So that's a good first step for life. Here we have a prototyped ultraviolet spectrometer that some students and I back at my university built. Last year we competed in the University Rover Challenge, which is a competition where students design and build rovers, and this was our payload. We're trying to perfect it now using an aqueous solution. So you take your sample and you powder it and you put it in this container, and then this is a diffraction grating that has been taped over it. It diffuses the light that comes through it. Let me plug in the power for you here. And this is easy to, we designed it and we assembled it here to prototype our project. So you have ultraviolet, near ultraviolet light come through here. It passes through the sample, becomes diffused by the diffusion grating, and you take a picture of it with this webcam. That webcam then displays it as an image like this. So the hope is that all 3 of these projects working together will help us get a better sense of what it's like to do geology on another planet and help us prepare for future missions.
A little while ago, I made a wish on a falling star, as they used to do many years ago. Now, the wish has come true. When we get away from here, we'll be living among normal people again.
I'm Hiroyuki Miyajima, a crew engineer. My job is to check and record the computer system and engineering system. For example, this is a computer network system, and this is a MDRS habitat activity logger prototype. This is temperature. And I have to check and record power station and fuel level and gasoline and propane and hub car and ATV and water tank levels. For example, there are 3 tanks, loft tank and static tank, trailer tank. It is difficult to manage these tanks. For example, I will show you this loft tank. Loft tank is this is loft tank. Could you? The motor is very noisy.
Hi, my name is Ian Etter, and I'm the crew journalist and artist in residence. I'm here at MDRS working on a project, Man-Marked Mars mission. I'm taking a lot of the practices here, and a lot of photography and video, and I'm going to incorporate it into this project. And I'm also here doing some observational drawing of what's out there in the port. See, it's pretty straightforward what I'm doing, just here as an observer. And I don't have any real science, I'm just taking it all in. So in the Man-Marked Mars mission, I'm taking some of the basic practices at MDRS, and I'm going to be building my own space station and going out into the Lost Hills of Mars for 2 weeks and setting up out there. I'm also going to be incorporating a lot of the imagery from here in photography, a lot of the imagery from the last 400 years of the observational history of Mars, and blending that into some of the imagery from the history of the American West in the Rocky Mountain Painting School, and blending all of this in together and creating this sort of fictive narrative that compares some of the parallels between the settlement of the American West and our previous desire and attempts to colonize Mars.
Hi, welcome to the Green Hab, and I'm here with the Green Hab officer to show you the hydroponic system that we've put in place. So it starts down here with a 20-gallon reservoir and a pump that's in the reservoir, and this will be filled with water and hydroponic nutrients. The pump is on its own power system to watch the power levels of usage, and it, if you want to look at this, it comes up from here, and in a T with a spigot, this hose goes back in so that the reservoir will mix. The reservoir and the water and nutrients that are for the plants will come up through this hose and split off here through 2 valves. A second one is on its way, but it's connected now so that this valve allows us to split the water and turn it on and off for 2 different sets of plants. So as the water goes through the valve, it comes down into the tray area and transfers to these hoses. These hoses then connect with small runners that have nozzles on them, and these nozzles will water the plants. And so we'll have 2 sets of plants, and our plans now are for one set to be for lettuces and the other set to be for peppers.
So coming up next, we're going to be installing this pH and electrical conductivity sensor in the hydroponic system to monitor reservoir conditions in the nutrient media. And if you follow me through here, we've been doing some work up here. We've been caulking and reworking this area where there's been a gap that's been leaking air after the half of the green had settled too low in the environment. So that has significantly helped us retain heat in the green hab, and since then we've also installed our new fan. So if you follow us back through here and look up, there's our hurricane.
So we've entered the space age with fans. This is what used to be here, and Charles hit the power. This is what we have now installed. And this keeps circulation going. It's a forced air exhaust so that the temperature gets regulated and the humidity through the season. So the last thing I'd like to show you in here is this light. It's called the Little Sun, and it was donated to us by the artist Olafur Eliasson, who does a lot of work with color and light, and he's made these for use on Earth at places that don't have electricity, and it's been perfect for use here in the Martian greenhouse.
Living on Mars wouldn't be any fun if you couldn't get outside and check it out. In fact, all of our research here, we all have to go outside on extravehicular activities, or EVAs. Now here we have some imagery of this landing site for our habitat. We're right here at this pinpoint, right on the edge of this pretty steep bluff here. This gives us some very varied geology to check out, which is something I'm interested in, as well as some very interesting sites to investigate for astrobiology and potential Martian life. So most of our traverses we've done so far have taken us from the habitat up north and around this interesting peak feature up here. We've also ventured out farther to the east where there's some ancient river cuts, and we can get an idea of the stratigraphy both above and below us. At the base of the mountain we have a long duration astrobiology project going on where they're planting and seeding algae and bacteria to see how the Martian environment affects them. Yesterday, in fact, we took ATVs out to do our traverse out around here, and that was a great experience too. We could really see the mobility of these rovers. Now, in order to meet all of our needs and all of our varied science objectives, we created this chart of how to execute our EVAs. Now, you don't go out on an EVA every day. It's a very dangerous and very complicated procedure. So we have them alternating every other day. This day was the Principal Biology and Astrobiology Survey Day. And then we had the Green Hab team go out 2 days later to collect soil for their greenhouse. 2 days later, the biology team will return to seed their astrobiology long-duration project, and we will continue to do geologic studies and to check on the biology studies as well. Let's go meet our crew engineer who's waiting for us in the EVA room.
Here is the EVA room. During the EVA, we have to wear these jumpsuits and helmet like this, and backpack, and GPS, and radio.
In order to get out of the habitat, we have to enter one of these airlocks, and then initiate our decompression sequence as well. We want to be sure we keep the pressure and air and temperatures inside the hab livable, apart from the inhospitable environment of the Martian terrain.
Commander's log, Mars date 1321224.4. Leave only footprints, take only pictures. Today, my footprints touched Mars. I led the away team on our maiden journey to the surface of the red planet. Our habitat must be located close to the North Polar region. Much of the ground was covered in crystallized water ice. Indeed, our dreams of a white Christmas Eva came true. Last night's activity will always stick with me. Geologist Bouchard led us in an illuminating discussion. He wrote 5 words onto cards: love, harmony, knowledge, power, security, and asked each of us to spend some time thinking about our interpretations of their meaning. We ranked them in order of significance and all shared our feelings with the rest of the crew. No one answer stands out. Rather, the holistic combination of opinion provided a glimpse into the conscience of the human condition destined for planetary exploration. The sounds of dancing echo from downstairs. The colors of expression flash from art in progress. Darkness deepens outside as a rainbow of Christmas lights reflect back in from the portal. The Hab is alive and yet not alone. Commander's log, Mars date 1321225.5. Last night we had our first freakout. Luckily for Crew 132, this was a fantastical film freakout of the finest fireball kind. Our modest living space transformed into a warmly lit theater for a screening of the Flaming Lips' Christmas on Mars, Commander's log, Mars date 1321226.6. Hydration is a key word for Crew 132, and the past day has alerted us to our water supply's role in daily life on Mars. Here at MDRS, we drink water, use it to rehydrate food and brew coffee, flush it down the toilet, and clean dishes and ourselves with it. On Earth, water flows freely. On Mars, it does not. The environment around our habitat is harsh and desolate. There is no babbling brook flowing with high-quality H2O. Our engineer calculated that our daily water usage is over 3 times that of the scientific reference volume published by a 2009 Flashline Mars team. Commander's log, Mars date 1321227.7. I suited up with 3 other away team members, excited for our crew's only planned rover excursion. We walked out of an airlock, down the steps, and mounted the nearby rovers. Only 3 started. As commander, I instructed one member to move to my rover and attempted to start his. It did not. I transferred EVA command and returned to the airlock as the away team headed off on a geology adventure. It was a long 3 minutes waiting in the airlock, alone in my spacesuit. Life, it seems, has gone full Martian. So we wish you all a happy holidays, and we'll talk to you on the next Earth year in 2014.
Happy New Year.
Yeah.